Hey everybody, welcome to InterviewBlog. In this video, we will be covering the question Invert Binary Tree. So the question gives us a binary tree and it wants us to invert it. That is, it wants us to convert the given input binary tree as if it is its mirror image. So if the given input binary tree is 1, 2, and 3, then we have to convert this binary tree into 1, 3, and 2. So before diving into the question, a short introduction about binary trees. Binary trees are nothing but collection of nodes, where the arrangement of these nodes represents a tree-like structure. So the topmost node of the binary tree is called as the root node, and the bottommost nodes are called as the leaf nodes. And each node of a binary tree can have a maximum of 2 child nodes. So each node of a binary tree consists of 3 properties. One is the value property, next is the left pointer, and next is the right pointer. So let us now consider the root node. So this node has a value of 1 and the left pointer points to the left node of the root node and the right pointer points to the right node of the root node. So this is how the nodes of the binary tree are arranged. So to access the left node, we have to use dot left property, and to access the right node, we have to use dot right property. So let us now see how to solve this problem. All right, so initially I'll be given the root node as my input. So here in this case, my root node is 1. So now what my algorithm says is, I'll be checking if the given node is not none. So in this case, you can see that the given node has a value 1 and it is not none. So what I'm going to do is, I'll be swapping the nodes that are pointed by the left and right pointer. So my left subtree would now come to the right side and my right subtree will now go to the left side. So let me just move this 7 and so now I have swapped the nodes that are pointed by the left and right pointer. So immediately after swapping, we can see that only the nodes in this level are swapped and this level nodes are not swapped. So we need to call this function recursively. If you are not familiar with recursion or if you are not comfortable with recursion, please do check out the video that we posted about recursion. So I'll be calling the invert binary tree function to the left node. So now I will check if this node is none or not. Since this node has a value 3 and it is not none, I'll be swapping the nodes that are pointed by the left and right pointer of the node 3. So my 7 would come here and my 6 would go to the right side. So we have done this swapping. So now again, my invert binary tree function will call this function on this node 7. So while calling this function on this node 7, we can see that 7 has the left pointer with the value none and a right pointer with the value none. So since both of them are none, even if we swap, it will remain the same. So the swapping here actually occurs, but it doesn't affect the given input binary tree. So after swapping, our function would check this left node of 7. Please note that our recursive function will also call for this none node. So for this none node, there is no left and right pointers. So we cannot perform a swap for a none node. So that is why we are initially checking if the given node is not a none node. So next we will be going to this 6 and we will be checking if the node is not none. And the node with the value 6 is not none. Hence we will again be swapping its left and right pointers, which are already none, and hence it doesn't affect our binary tree. So now we'll be visiting this node with the value 2, that is invert binary tree of right will be called, and our function will check if the node is not none. Since the node has a value 2 and it is not none, we will be performing swaps. That is, we'll be swapping the node with the value 4 to its right and we'll be swapping the node with the value 5 to its left. So after the swapping is done, we'll be recursively calling our function for these two nodes. But we can see that these nodes has a left and right pointer that points to the value none. So there will be a swapping performed, but even after this swapping is performed, it doesn't affect our input tree. Please note that our recursive function will also call for this none node. So for this none node, there is no left and right pointers. So we cannot perform a swap for a none node. So that is why we are initially checking if the given node is not a none node. So hope you understood the problem. Let us now analyze the time and space complexity of our solution. The time complexity of our solution tends to be big O of n, where n is the number of nodes in the given input binary tree. This is because we are visiting each and every node at least once in the given input binary tree. Hence, our time complexity tends to be big O of n. The space complexity of our solution tends to be big O of h, where h is the height of the given input binary tree. So the space complexity tends to be big O of h because we are using recursion, and during the program execution, at a point of time, there are a maximum of h nodes that are stored in the recursive call stack. Hence, our space complexity tends to be big O of h. So hope you understood the problem. Let us now implement it in code. All right. So we got our invert binary tree function defined, which gives us the root of the input binary tree. So what I'm going to do is I'll be checking if root is not none. So whenever my root has a value, I will be swapping the left and right pointer of the root. So before doing that, let me just create a class which is a binary tree node, and this node has three properties. So the first property is value. The second property is the left pointer, which is initialized as none. The third property is the right pointer, which is also initialized as none. So let me just comment it out. So now what I'm going to do is I'm going to swap the left and right pointers. So to do that, I'll be saying root dot left, comma, root dot right is equal to root dot right, comma, root dot left. So I'm actually swapping the left subtree with the right subtree. After this, I'll be recursively calling invert binary tree of root dot left and invert binary tree of root dot right. So after this, I'll be saying return root. So this will be our solution. So this solution has a time complexity of big O of n and a space complexity of big O of h, where n and h are the number of nodes and height of the given binary tree respectively. So hope you understood the problem. Let us now test our solution. So let me just copy our solution. So this is Leetcode problem number 226, which is invert binary tree. This is the same problem that we discussed right now. And here we are having the tree node, which has three properties. That is the value property, the left property, and the right property. So let me just paste our solution. And we'll be saying return invert binary tree of root. So let me just run our solution. So yes, our solution got accepted. So let us run all the test cases. And yes, our solution works fine. So hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.